everyone, and welcome to our educational session. My name is Paul Arsov, and I'm the founder of the Decentralized Web project. I'm going to talk about our project and several other projects in the end of this presentation. But the topic today is structure of biological intelligence and its implications in building of artificial intelligence. In the shadow of artificial intelligence towering achievements, like for example machines that paint masterpieces, unravel genomes, and converse with early fluency, lurks a question as old as the philosophy itself. What is intelligence? For decades, we have built AI on the bedrock of mechanistic precision, crafting systems that mimic human feats through a sheer computational might. Yet, recent revelations from biology suggest that intelligence, in its deepest essence, may not be a product of top-down control, but rather an emergent dance of countless tiny agents, each imbued with purpose and autonomy. This presentation explores two transformational concepts: agential matter, drawn from the work of researcher called Michael Levin's on bioelectrical insights, and nano-intentionality, proposed by a scientist called Tecumseh Fitch, and their profound implications for AI. By juxtaposing the distributed genius of living systems against the synchronized rigidity of modern computing, we confront a radical possibility. To truly rival biological cognition, AI must abandon its mechanistic roots and embrace the swarm-like autonomy of life itself. Intelligence, it turns out, is not the exclusive domain of our brains. Michael Levin's pioneering research into bioelectrical computation reveals that even single cells possess a startling capacity for problem solving. These microscopic marvels navigate objects, retain traces of past encounters, and coordinate with their peers to achieve collective ends. In multicellular organisms, this ability scales into feats of breathtaking complexity. Tissues sculpt themselves through controlled morphogenesis, repairing damage and adapting to disruption without a central overseer. Levin's experiments altering bioelectrical gradients to reprogram cellular decisions about shape demonstrate that cells are not passive cogs into a genetic machine. They interpret signals, weigh options, and collectively grow towards stable forms, embodying what Levin calls agential matter. This notion of agential matter upends the traditional view of biology as a hierarchy of obedient parts. Cells, like ants in a colony, exhibit swarm intelligence, a phenomenon where simple agents following local rules give rise to sophisticated global outcomes. But Levin's work suggests something more. These agents are not just reactive but goal-directed, searching for solutions with a proto-agency that defies mechanistic behaviors. In living systems, intelligence is not imposed from above, but it emerges from below, a symphony of small, purposeful players playing together. And what about nano-intentionality? If cells are agents, what drives their directedness? W. Tecumseh Fitch offers an answer with nano-intentionality, a concept that locates the roots of purpose at life's smallest scales. Nano-intentionality posits that molecules, cells, and neuronal processes possess an intrinsic aboutness, a minimal built-in orientation towards goals that aggregates into the rich intentionality of conscious minds. The idea echoes Daniel Dennett's vision from bacteria to Bach and back, where neurons are cast as autonomous competing agents, miniature robots responding to local cues, not puppets of a central conductor. Together, Fitch and Dennett paint a picture of intelligence as a distributed phenomena arising from the interplay of countless nano-intentional units. This perspective challenges the reductionist lens that sees life as a mere physics and chemistry, where a mechanistic worldview finds only inert particles. Nano-intentionality reveals a subtle spark of purpose, a foundation upon which higher cognition is built. In the brain, neurons don't await orders, they act, react, and collaborate. Their collective chatter weaving the tapestry of thought. Biology, it seems, thrives on autonomy at every level. To grasp why this matters for AI, we must rewind to the dawn of parallel computing, where two paradigms clashed: single instruction, multiple data, and multiple instruction, multiple data. SIMT, exemplified by the connection machine, a project aided by Richard Feynman, synchronized thousands of processors under a single command, each crunching different data in unison. In MIMT, in contrast, unleashed independent processors to tackle diverse tasks, trading simplicity for flexibility. Over time, supercomputers blended these approaches, but today's AI, particularly deep learning, leans heavily on SIMT legacy. CPUs and tensor cores, the workforces of neuronal networks, excel at vector and matrix operations that power forward passes and back propagation. Yet this structure and architecture comes with hidden costs: centralized synchronization. In deep learning, gradient descent imposes a global rhythm. Each neuron or layer adjusts its weights in lockstep. guided by a shared error signal from a top-level training loop. This is a triumph of emergent efficiency, but it bears little resemblance to free-willing autonomy of biological systems. Imagine a brain where every neuron waits for a conductor's button, an absurd parody of nature distributed design. Current AI, for all its prowess, operates as a mechanistic monolith tethered to the very paradigms biology did transcend from. Swarm intelligence offers a stark contrast. A truly swarm-like system thrives on five principles: awareness, where each agent senses its environment; autonomy, granting independence to act; solidarity, fostering cooperation; expandability, allowing growth; and resilience, ensuring self-healing. Ant colonies, immune systems, and Levin's morphogenetic tissues embody these traits, adapting to challenges with fluidity and that deep learning lacks. In AI, neurons are passive, summing inputs, firing through fixed instructions, and updating via external routines. They don't search for solutions as cells do when healing a wound. They follow orders. The gulf prompts a question. Are we shackling AI potential with synchronized control? Some researchers advocate for MIMT-like models where computational nodes act with greater independence, spontaneously adapting or redistributing tasks. Such systems might mirror biology emergent behaviors like self-repairing, resilient, and open-ended in ways that gradient descent cannot replicate. Fitch's nano-intentionality raises a deeper conundrum. Can AI built from non-identical silicon ever possess the aboutness that defines life? He argues that machines represent and choose only metaphorically, lacking the intrinsic awareness that a nano-intentional component confers. Truly mental learning and awareness, Fitch writes, are composite reflections of more fundamentally and intrinsically nano-intentional capacity in biological neurons. By this logic, deep learning's artificial neurons, devoid of inner purpose, may hit a ceiling, excelling at tasks but never grasping their meaning. Counter-argument emerges. Perhaps neural networks cultivate a latent nano-intentionally through training. Their weights, sculpted by data, encode representations about the world, suggesting a functional echo of purpose. But this is a shadow of biology's reality, where cells and neurons act with an innate drive that silicon lacks. The debate remains open. Is intrinsic intentionality a prerequisite for true cognition, or can we engineer its semblance from lifeless parts? As biology and computing converge, we face urgent questions. First, are we building AI on flawed premises? If intelligence stems from agential matter and nano-intentionally, can synchronized top-down systems ever match nature's adaptability? Second, what would autonomous AI look like? Could computational cores with genuine accuracy, free to adapt, collaborate, and self-repair, spawn emergent intelligence beyond our current grasp? Third, can machines heal and evolve? Biology is self-directed tissues suggest a model for AI that regenerates and reconfigures qualities absent in today's brittle architectures. Um, and then fourth, how do we cross the divide? As hardware decentralizes, more must algorithms follow, embracing the messy swarm-like autonomy of life. Biology whispers a truth we have yet to fully heed. Intelligence is forged into a crucible of agency, from cells that probe their worlds to neurons that weave their own narratives. Modern AI, for all its brilliance, stands as a monument to mechanism, efficient, predictable, but alien to life's restless creativity. The path forward lies in systems that mirror nature design, distributed, resilient, and alive with purpose. By endowing artificial agents with the autonomy of their biological kin, we might not only mimic intelligence, but ignite it anew, bridging the chasm between silicon and soul. And with this set, I'm ending this educational presentation, and I'm coming back to the beginning of this presentation when I told you that my name is Paul Arsov, and I'm the founder of the Decentralized Web project and several other projects. In the Decentralized Web project, we're building a decentralized communication and advertising platform. We have our own blockchain instance, and this blockchain instance rewards people who are joining our decentralized web platform with tokens, and our users are also rewarded for inviting other people to join our platform, and the users on our platform are also rewarded for viewing advertising on our platform. The advertising part is very, very permissive. Like, for example, you click a button to start viewing advertising. Then there is a screen which you could view for a few seconds, and then there is a button to advance next to the next ad presented. And with this set, I'd like to tell you that our implementation of decentralization is different than the way like blockchain technology states they represent decentralization. We view blockchain technology as fundamentally flawed and unsuitable to drive decentralization. And in our implementation of decentralization, we uh, implement decentralization as a direct communication from user to user without going to a third party, namely a server or a central point which collects data and then it distributes back this data to the users. In our implementation, we do always direct communication from user to user. And with this said, I'd like to tell you about the second project that we built and released. And this second project is marketplace and collection of non-fungible tokens or NFTs based on three-dimensional objects. With three-dimensional objects, there has to be special software which loads and displays the 3D object, and usually creators of 3D objects, they are using standard software, and currently the most popular choices are two game engines. One of them is called Unity and the other one called Unreal. But from the very beginning of our decentralized web project, of our 3D NFT project, we decided to build our own 3D software engine, and what it does, it reads the file of the 3D object, then it opens a window on a computer screen, then it displays the 3D object, and then it starts animating the 3D NFT in a way of moving it in a random fashion around the window it did open. But in addition to these initial and basic capabilities, our 3D software engine has multiple additional capabilities. The first additional capability of our 3D NFTs is the capability of speaking. Our 3D NFTs can speak in one of three different voices. The 3D NFTs can speak either in a male voice or in a female voice or in a whisper kind of a voice. In addition to the three basic voices, there are three different flavors of voices. A voice can be spoken in a normal speed fashion, or in a fast speed fashion, or in a slow speed fashion. And if we take a male 3D NFT speaking with a male voice, and it is spoken in a slow speed manner, then this voice can come as the voice of a masculine person or the voice of an old person. And if we take, for example, a female voice and it is spoken in a fast speed manner, then this voice can come as the voice of a little girl or the voice of a funny person. The next additionally important capability of our 3D NFTs is the capability of voice recognition. The 3D NFTs can recognize voice commands, and for example, if we have a 3D NFT which is animated and moving in a random fashion, then we can issue our very first voice command to this 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. We can issue following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go further away, zoom out, and start rotating. The next additional important capability of our 3D NFTs is uh, the capability of them having a basic artificial intelligence. Wow, really, wow. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to reply in few sentences of who they are. You can ask the 3D NFT to describe something. For example, describe Web3 or describe decentralization or describe Russia. And then the 3D NFT is going to reply in few sentences about Web3 or decentralization or the country called Russia. The last additional but not least important capability of our 3D NFTs is the capability of them being displayed in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or cyan colors. Then you can come to our 3D NFT marketplace website, and probably now is the time to tell you the name and the URL of the website of this project. It is 3dnft.decentralizedweb.org. 3dnft is typed in a way of the number 3 followed by the letter D followed by 3 other letters NF T, and it is typed all together 3D NFT. Then there is dot, then there are two words typed all together, decentralized and web. Then there is dot and it ends with org. Once again, 3D NFT dot decentralizedweb.org. On the top of the main page and every other page, you can see number of links. One of these links points to links to accessories, and when you click on this link, you're going to see that we're offering special glasses. When you click and order one pair of these glasses, and when you receive these glasses, you're going to see that one lens of these glasses is red and the other lens of these glasses is blue cyan. Then you can put these glasses on and you can request displaying the 3D NFT in a way of stereoscopics, and then you're going to see the 3D NFT coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions. And with this set, I'm ending talking about our 3D NFT software engine and 3D NFTs collection, but I like to mention about our 3D NFT marketplace. In our 3D NFT marketplace, we have our own blockchain instance, and we do not charge our users for deployments of the smart contracts for the non-fungible tokens, and we do not charge our users for transactions of transfer of ownership from one user to another user. In addition to this, we allow buying and receiving proceedings from sale, not just in a single crypto coins, but currently in 4 different crypto coins. The choices currently include Solana Sol, Polygon Matic, Avalanche Avax, and Qcoin, which is a big centralized crypto exchange. They have a coin called KCS. In addition to buying and receiving proceedings from selling crypto, we have a second parallel and independent way of buying and selling 3D NFTs, and it is done entirely in fiat currency. So let's say you are a user, you come to our 3D NFT marketplace, you click and browse through the collection of our 3D NFTs, and you click and like in particular one 3D NFT that you like to purchase. Um, then you're going to be presented with the page of this 3D NFT and a drop-down menu which asks you to select a way of payment between 4 different crypto coins and a fifth choice of paying with fiat currency. If you select payment with fiat currency, then you're going to advance to the next screen where you have to put the number of your debit or credit card, expiration date, CVC, and when you click on the button to complete the transaction, what is going to happen is there is going to be a transaction and transfer and conversion from your national fiat currency, which could be different than US dollars, and the payment is going to be deposited in our bank account in US dollars. Then we're going to transfer the initial ownership from our 3D NFT marketplace, and this transaction is going to give you ownership of the 3D NFT, and you can play with this 3D NFT for a while, and at some point you can decide to put it for sale. When you click and put this for sale, let's say there's a second user, they come to this 3D NFT marketplace, they browse through the collection, and they like in particular the 3D NFT that you put for sale. What is going to happen is the second user is going to go through the same steps of choosing between 4 different crypto coins and a fifth choice of paying with fiat currency. So let's say they select paying with fiat currency, and then what is going to happen is then they're going to put their number of debit or credit card, expiration date, CVC, and when they complete the transaction, there's going to be a transaction and transfer and conversion from their national fiat currency, which could be different than your national fiat currency and different than US dollars, and it is going to be converted to US dollars and deposited in our bank account. Then we're going to transfer the ownership from you to the second user, and now the second user becomes owner of this 3D NFT. Then we are going to do a transaction and conversion from US dollars to your national fiat currency, and the payment for the purchase of 3D NFTs is going to be deposited in your bank account in your national fiat currency. And with this said, I'm ending talking about this project, and I like to come back to the first project, Decentralized Web Project, and mention that its website is decentralizedweb.org. Decentralized and web, these are two words, they're typed all together. Decentralized web, then there's dot, and it ends with org. The next project that I like to mention is a project that builds charging products for electric vehicles, and currently we estimate that the number of electric vehicles in existence is going to exponentially grow up, and at some point it is going to become a problem charging of these electric vehicles. Currently, the way of charging of electric vehicles is handled in a way resembling the gas station model, where internal combustion engine vehicles are coming and loading fuel in their vehicles, and then they're leaving. In the same way, there are charging stations with a number of charging columns where owners of electric vehicles they come to these charging stations, they connect charging cable to their electric vehicle, they identify themselves to the charger, um, they wait for a while their vehicle is loaded with energy, and then they pay for the energy loaded, and finally they leave. But we estimate that the number of these charging stations is going to become ultimately insufficient to charge the exponential growing number of electric vehicles. So what we are proposing is like we call it parking lot model, and many of the electric vehicle owners, they are living in cities, and they are also living in apartment buildings which are outfitted with a ground floor parking lot or multiple underground floors of parking lot. So what we're proposing is outfitting these residential buildings parking lots with charging products like the type of charging products that we're building, and in these parking lots the owners of electric vehicles they can come from work in the evening, and they can connect electric cable to their vehicle. They can identify themselves to the charger by their debit card, credit card, or near field communication card, or keychain token, near field communication keychain token, or near field communication ring, which the user could wear. And then they can request charging of the electric vehicle and leave their electric vehicle to charge during the evening, during the night and early morning while they're at home. But some electric vehicle owners, they're also working in high-rise office buildings, and these high-rise office buildings are also outfitted with a ground floor parking lot or multiple underground floors of parking lot. In the same way, these high-rise office buildings could be outfitted with the types of charging products that we're building, and they could offer charging of like when the owner of the electric vehicle comes in the morning for work, they could connect electric cable to their vehicle, and they could request charging of their electric vehicle during the morning, during the afternoon, and early evening while they're at work. With this said, I like to tell you the name and the URL of the website of this project. It is power.rstack.com. Power is the ordinary word for power, then there is dot, then there is a word which I can spell it letter by letter. It is Alpha Romeo Sierra Tom Echo Charlie Hotel. Altogether rstack, then there is dot, and it ends with com. Once again, power.rstack.com. On the main page, you can see that we did put 3 different surveys, and you can click and fill each one of these surveys. One of them is about the hardware, the second one is about software, and the third one is about features. And by filling these surveys, you can tell us about the needs of charging products, and we could outfit one of our existing products, or build a new product which could satisfy your needs. And also we put an article which compares the gas station model versus parking lot model, and it tells in very big details about the types of products that we are building. And with this set, I like to tell you about the next project that we built and recently released. This project has artificial intelligence agents, and these artificial intelligence agents, each one has its own gender, its own voice, its own pitch of the voice, and its own avatar, and its own large language model. And like there are currently two different artificial intelligence entities in this project, and you, the user, specify the gender of each one of these AI entities. You specify the voice pitch, the avatar, and the initial prompt for the large language model of each one of these separate AI entities. With this set, I also like to tell you the to give you an example of interaction. Like after specifying the parameters, you click to start the interaction, and you, the user, just observe this interaction between these two different AI entities. For example, you can specify the first AI entity to have a female gender, female avatar, female voice, and specify in the prompt that it is very seductive. And the second AI entity, you can specify to have a male gender, male avatar, male voice, and their own large language model, and you can specify their initial prompt to for this male entity to be very angry. And then when you click on the button to start the interaction, then you're going to see the first and female AI entity trying to seduce the male AI entity, and then the male AI entity responding in an angry way to the first AI entity. And you can see this AI interaction going back and forth. At some point, you can stop this interaction. You can request to have a transcript to save for yourself of this interaction that you can view at a later point. And also you can save the parameters of this interaction and share these parameters with other users on our website. And with this set, I like to tell you the name and the URL of the website of this project. It is ai2ai.decentralizedweb.org. AI to AI is typed in a way of the letter A followed by the letter AI followed by the number 2, followed by the letter A and I. Once again, AI to AI dot decentralizedweb.org. With this project, you can specify your own interactions, and examples of these interactions are, for example, like one AI entity being a salesperson, and the second AI entity being a customer wanting to purchase, for example, a car or purchase like washing machine in a store. And with this set, I like to tell you about the last project that we're working on. This last project builds automation tools which for the user, for example, are having specific task in mind. For example, purchasing some specific food item from a specific food store, or looking for this food item throughout multiple food stores. And then you can go through the number of the interactions on the websites, one or more websites, and the automation agent that we are building is going to record these interactions, and it is going to then remember these interactions, and you, the user, could put a label on this sequence of interactions. And for example, like you can label buying like this specific food item as a label, and then when you tell the automation agent buy this specific thing, then the automation agent is going to go step by step through the interactions, and it is going to pause at the final interaction where you click and make the payment and agree to purchase this item. In addition to buying food items, there could be many other interactions that could be automated, like for example buying a ticket for an event, which is a concert or like a movie, or buying like searching for a flight through multiple websites like airlines and like aggregators of airlines. And you can specify the range of the dates. You can specify like maybe a specific airline or number of airlines, and then you're going to get offers for tickets, range of dates, and you can automate this interaction to and label it like for example purchasing an airline ticket. And with this set you're going to have this interaction automated up until the task of choosing and the task of paying, so that you do not have to go through like search manually, but rely on the agent to do the search for you. With this set, I like to tell you that we do not have yet website for this project, and we're building this project as an answer to the project called Atlas of OpenAI, where they built a browser, and this browser is looking at automating interactions. Our automated agent do not only work in a browser environment, but would be working in ordinary programs which are started on your computing device, be it a laptop or a mobile device or a tablet. With this said, I'm ending this presentation. Thank you for listening. Thank you for viewing. Have a nice day. Have a nice evening, and goodbye.